All right, I haven't uploaded the the initial makefile, source code, and test files. I will do that shortly after class. Let's go ahead and talk about your Lab 12. Hopefully it's not a surprise to anyone, but we are doing stacks and queues. Oh, cool. I'm allowing you to use the STL vector. Oh, that's, whoa. Oh, this lab just became super easy. All right. I don't even know if I've... What's that? All right. Implement a stack or a queue with whatever data structure you desire. Remember, you may only use code from a previous lab or the STL vector and list. You may not use STL's queue and stack, okay? Everyone got that? Good. So what are we doing? We implemented this in class. It kind of wasn't that bad. Do a deep copy of a stack into this one. So, I'm sorry. Empty constructor, I want to be able to pass you a stack and you'd be able to copy it. Don't forget to deallocate your memory. Get the length, how many elements is empty. You know, if you do get length first, is empty is going to be pretty easy. This print is only for your own testing purposes. There we go, push. Notice push in this case returns a Boolean. I don't know why it would return false. It better always return true. So we're going to do t at, which is top, removes the top or returns the top element. If you should assume that if the stack is empty and I ask for the top element, that it's just going to error out, and that is fine. Pop should remove the top element of the stack, and then double equals return if two stacks contain the same elements in the same order.
Nice.
Make sure you don't delete anything when you do that. Hey, look, it's a queue. Same thing with empty. Same thing with the deep copy. Get length is empty print. Push, same thing. First, it's called first. Last time was called top. It's the same function. Well, very similar. And then pop. Only difference is you push to the back, and that's it. Everything else is the same. Everyone got that? Good. You may use vector, string, and lists from the STL. Do you want me to go over those in this? We have some time if you want to go over them.
Just real quick.
Just real quick? All right, we'll do that momentarily. Write some test cases, memory management, ensure there's no leaks. It's due a week from today. All right, we want to go over the STL. Sounds great. I'm kind of afraid of what Firefox is going to show when I load it up. STL, we'll do vector. So, 6 styles of love, people quitting, 7 cards, charging 0% interest. Alrighty then. One of these will load up. Oh, we don't care about that. Oh, here we go. The STD vector. Alright. Construct a vector. Look at all this stuff. Alright, let's go over and play with it. Alright, you want a vector, and you probably want a vector of something. Let's make a vector of ints. Sure. Vec. Vec may have something called, I don't know, push front. Actually, I don't know if it actually has push front. Does it have push front? Nope, it doesn't. It only has push back. Haha. Push back. All right, there we go. We'll do 42.
Didn't even ask this time.
1, 2, 3, 4, 3, 10. And then we can do, we'll do std, cout, vec.back. I don't know if I'm typing this correctly, by the way. Let me find out. I'm going to do make. Oh. It did. Okay. And vec.back was a 10, so we'll do vec.pop. pop back. So that should be the 3, 1, 2, 3, 4, 42, right? So we're pushing a bunch of numbers, and then we're going to print what's in the back, and then call pop back. I'm going to make it first. Gen 3, 1, 2, 3, 4, 42. Is that in reverse order? Does that seem helpful?
Maybe just a little bit.
So what is a vector? Vectors are sequence containers representing arrays that can change size. So it is an array that automatically adjusts the size as you push and pop from it. Wouldn't that be nice to have? Well, can you take a guess at what a list is? Lists are sequence containers that allow constant time insertion and erase operation anywhere within the sequence, and iteration in both directions. List containers are implemented as a doubly linked list. Now let's go here, std, we'll make this a list. List. And this time, the list you can push back, but instead of doing, oh man. Alright, so we can push to the back, which is great, but lists have this nice feature where you can also pop from the front. Doesn't that seem helpful? Yeah. Oh, I don't know what that was all about. Let's see what I did wrong.
I think you're only calling the back.
Oh yeah, I'm only calling back. I'm going to call the front. Good call. And then 42, 1, 2, 3, 4, 3, and 10. That might be a little hard to see, but let's go ahead and, so we're going to put a little divider in here. Huh. How's that? It's called the STL because it's templated, meaning that you can have a vector of whatever you want.
Well, that will be very difficult.
What's that?
Well, that sounds like it will be very difficult.
Oh man! The other nice thing about these classes is that they will automatically deallocate themselves when they go out of scope. Notice I did not make a pointer. It is handling the pointer or the dynamic memory for you inside of the class. Now, if you created the vector with new, then you would have to call delete on the vector afterwards, which you can do. Or you can make it static, because C++ allows you to have classes on the stack. And when you do this inside of a class, it's just part of the class, which is fine. And what that means is that this vector here will be deallocated automatically down here. Same thing with the list. And just to show you, if I run Valgrind on main, everything's been deallocated. That was a lot faster than I anticipated. Any other questions? Well, let's go look. Before actually I say any other questions, list implements doubly linked list, etc., etc. We're not going to talk about iterators right now. Capacity, there's empty to tell if it's empty. Size to return the size. Max size. Okay. The front element, the back element. We got push front, pop front. We got push back, pop back. We can insert in the middle, erase. We're not going to get into some of these yet. I don't know why we want to resize the list. We can remove some elements. Ooh, we can do merge, and we can call .sort. And we can reverse it. Wow, that's nice. In a vector, size, max size. Now here and capacity. So remember, I was trying to use the word capacity because capacity is how many elements that's actually allocated for your vector. Size is how many you're actually using, I believe. Yeah. You got empty. Look, you have operator subscript, but list does not have that subscript operator because it's not a very fast one for a linked list. And also in a vector, you only have push back and pop back. Again, because they want to discourage pushing in the front because that would be a really slow operation. And you can erase something in the middle. And we're not going to go through all the other ones. We're going to save that for later. And I think that's it. All right, now any questions? Comments? Streams? All right.
Size of relief.
What's that?
Size of relief.
Size of relief. All right, that is all for today. I will see you on Wednesday.